One major component of the basis of chemistry is understanding two major properties that they exhibit. And in this session, we want to take time and actually look at those two properties because um, they are going to be the subconscious property that we'll be having in mind in solving a lot of problem. Yes, a lot of problem, a lot of things, and explaining a lot of concepts, right? Yeah. But before that, let's look at an assignment that we promised that we'll give you in this current video from the previous one. So this is the assignment that we have. Yes. So for the assignment, you are just to classify these substances um, into whether they are mixtures or they are pure substances from what we learned the previous time, right? These are all matter. So the first one, you have salt, then you have seawater, then you have soil, you have air, sugar, and then water is of. Okay. So we want you to be able to classify them in the whether they are pure substances or not. So we'll be getting the solution in the next session, right? So for this one, try your hands on it. If you watch the previous video, you should be able to be fine. You'll be fine with this one. Okay, so let's go to the business of today. That's two properties that matter exhibits, right? We want to look at these two properties. So the properties that we have, first one, we are going to have a physical property. So matter exhibits two major properties, right? So physical properties, that's the first one. And then it also exhibits chemical properties. We said it indirectly in the previous session where we said some of them you can just use chemical processes to separate them. That's mixtures, right? But let's look at physical properties. So what's a property? Property is just a characteristic that something exhibits. Okay, so characteristics or that is peculiar to a particular substance. That's what we just call property. Okay, so we have physical property exhibited by matter and then chemical properties exhibited by matter. What do we mean by physical property? So we are going to do this reference to in reference to what they contain, their composition. Okay. So for physical property, right? If matter is exhibiting physical property, it does change. It undergoes some change without changing its composition, like what it actually contains, right? It doesn't change that. Remember, we learned matter into properties, right? We said matter can be classified for solid, liquid, and gas. That's the states, right? Those things are physical properties. And then for the chemical property, we also look at substances and all that. And then we said based on their composition, right? We had another classification. Okay. With those composition, if matter is undergoing change and that composition, his composition has changed, right? Or his composition has does not change its physical property. If the composition of the matter after undergoing changes, then it's a physical does not change. Sorry, does not change physical property. But if the composition changes, then it's a chemical property. Again, matter usually undergoes change. There are cases where matter undergoes change from the definition of chemistry. Now, after undergoing the change, we have to look at the matter again, the new change form. If its composition has been changed, after matter transforming into a new substance, right? After matter transforming or undergoing a particular change, we want to see if the composition of that the changed substance is the same as the previous one or it has changed. If it's the same, then it's just a physical property. But if the composition is has changed, then it's a chemical property. That's basically that. So chemical property affects the internal composition of a substance, but physical property does not change that. Basically that, right? So it's more of who attacks or who affects the chemical composition of matter, and then which one does not. Chemical property affect the internal composition. Physical property does not. Let's look at some examples. Now, first example, we have this. This is ice. You see, ice is melting into water. So you see the ice, which is solid, right? It is changing into water. So we are seeing some particular change here. Okay, so if you take the ice itself, right, the chemical composition of ice is water, is still water, but just like it is having a solid form. Solid form, that's physical, right? Physical, solid form. Now it is going to what? The liquid state. This is the liquid state of the water. So this one too, if you take the chemical composition of this one too, you're going to have H2O. So you see that it's still water, 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 right? The the melting is just a physical process, not a chemical process. How do you know that? You check what was there, internal composition of what was there for, which is the ice, it's H2O. Then the internal composition of what has, or the result of the change. The result of the change is water, like the liquid form of it. Change from solid to liquid. So change of solid to liquid, then we just still have water without affecting the chemical change. At the end of the day, this process is just a physical change. So water is exhibiting a physical property in this case, right? Let's look at another example. In this case, we are cutting a paper into two, right? So we are having the full paper first, then we are using scissors to cut it. So after the cutting, what do you think? Then we have this and we have this. We have this and we have this. What do you think? Is it a physical property or chemical property? This is still paper, right? This half is still paper. This other half is also a paper. So the composition before and the composition after making the change, right, is the same. The composition, what they contain first and what they contain after, is the same, right? Then it's just simply a physical process. So physical process does not affect the internal change. So cutting of paper is just a physical process. So matter is exhibiting, or this particular paper is just exhibiting a physical property. Let's look at the next one. So now here we are having burning of firewood. Burning of firewood. You see, the firewood is turning into this white substance, right? This white substance is like, oh, ash. This ash, right? We're having ash itself, right? Okay. Now the question is the combination of wood first. This wood, of the wood first, and then the ash. Are they the same? That's the question after the burning. So burning, we are undergoing some change over here. Uh, chemically, they are not the same. Chemically, they are not the same. So ash and wood are not the same chemically based on the chemical composition. So yeah, we agree that we have to know that we have to note that for chemical process can affect the physical form and the internal composition. So in this case, wood is solid, right? It's very, very solid on its own. And we are seeing it in this physical form first, hard, very hard. When after burning it, it becomes ash, which is soft, right? So physically, we can see that there's a change physically. But then when we check its composition too, its composition is not going to be the same, right? It's not going to be the same. When we are doing combustion or when we are burning, we are actually adding an oxygen to a substance. So this is substance plus oxygen. Basically, that's one form of it, right? We are adding this to this chemically. So the substance itself was there, then you added oxygen or whatever, it affects the internal composition. So ash, this particular process of combustion or burning is a chemical process, right? So I said chemical process, right, has the ability to change both the physics and the chemistry, both the physical composition and the chemical composition, right? That's what we can see for chemical process. But physical process, they only change the physical states, right? They don't change the chemical composition. But chemical composition has the ability to change both. Okay, in this case, you can see that ash has changed, the solid wood has changed into soft wood. That's a physical component being changed, and also the internal composition too has changed. So this one is a fully a chemical process. So chemical process fully qualified when you have the internal composition that has been changed. Let's look at this next one. So in this example, we can see fruit juice. This is my fruit juice, right? This is fruit juice. Um, it is sour. It has fermented. It has fermented. So we're not having it first, but after leaving it for some time, it has just fermented. So I hope you have tasted a fermented food before, right? The taste changes, right? Sometimes the food may be looking nice, the same as how it was, right? So you may not quickly identify the physical change, right? You just be looking at it and then you think that, oh, this is nice. But if you taste it, it gives you a different scent or different flavor or different sweetness, or bitterness, after you tasted it. Then you realize that, okay, the physics is the same, like the physical composition is the same, but the internal composition has changed. That's why. So this one is a chemical process. Fermentation of food, right? It's a chemical process. So chemical property has been exhibited over here. So the fruit juice is now sour now, even though it's still in the liquid state, right? It's still in the liquid state. This one, you can see some solid. So it kind of give you an idea on the look. but then it's not necessarily all the time. Sometimes the thing will still be the same after some days when you come, or you see that, or you physically you see it and it's the same, but then if you taste it, then you see that the taste has changed, right? That one, you know, you can only detect it, meaning that there has been a change internally, and that's a chemical process. So again, chemical process can affect what, both the physical composition and then the chemical composition. But physical composition can only change the physics, that's the look, the shape, and all that, right? Yeah, let's summarize everything. So yeah, so we have physical property change and a chemical property change, and then you have to know that for the when something undergo physical property, right, it is reversible, meaning that you can, when you make a change to through a physical process to get another thing, right, a deformed substance, you can do the reverse and go back to the original substance. Physical process property do that. Chemical property is irreversible. Irreversible. You cannot go back after the change. If it undergoes chemical process, you cannot exactly go back after the change. Now, physical property to yes, we said that many times. This is a basic thing, basic difference. No change in chemical composition, but a chemical property change undergoes what, exhibit change in chemical composition. That's the basic difference, right? Huh. Physical property, what are no new substance is formed. So for in the case of the ice, right, ice and water, we have the substance ice. There's the name is changed, but like the substance itself is still H2O, and then the liquid is still H2O. So there's basically no new substance formed. They're just changing the shape, how it look like, but then the substance is still the same. Why, right? So no new substance is formed. But then in chemical properties change, you can see a new substance is formed as well. For example, in terms of wood, we say we add oxygen to the substance, then become has a different name. Some things are lost, some things are gained. Then chemically, different things are gained. So that whole thing itself is a different substance on its own, separate from the previous one. The paper, when you cut it into two, what you have here, what you have here, they are all paper, the same paper, no new changes. That's a physical process. So examples of processes that you can see, you have phase changes, right? That's phase changes, solid to liquid, liquid to gas, sublimation, condensation, and all that. They are the phase changes, right? The phase changes are all physical processes. Then the other thing is that you can change the shape of the thing. Just changing the shape of the thing does not affect its chemical composition, or change the size. Like the paper was huge, we cut it to make it smaller. We are just having a physical process. So that one is just changing size. Chemical property, chemical properties, some of so chemical reactions there out there, right? Yeah. Oxidation, we'll look at these things. These are processes, chemical processes that we'll be seeing throughout in our studies, right? Combustion, that's burning. We've seen one already. Combustion, the corrosion of metal. So right, we have iron that is rusting and all that, or the iron that you had first is not the same as the previous, the current one, the rusted one, so they are not the same, right? So yes, those are processes, common processes. So at least take from this lesson that chemical properties change, right? No touch, no attack to the internal composition, but chemical properties attacks the internal composition, and then the phase change. You know the common examples of um, physical and chemical processes. Then you have these common examples. So in the next session, we'll continue with another concept. Stay with us so that we continue building our concept and become very good with the basis of chemistry.